Alright, what's up guys? In this video we're going to pick up some multivariable calculus, and this question is asking us to find the volume of the tetrahedron having the following vertices. So you got these vertices here. We got 3 comma negative 1 comma 1, 4 comma negative 4 comma positive 4, 1 comma 1 comma 1, and 0 comma 0 comma 1. And we want to find the volume of this tetrahedron. So the first thing I'm going to do is I'm going to label these vertices here using vectors. So this would be 3i minus j plus k, because a unit vector is a dimensionless vector with a magnitude of 1, so you never have to place a 1 in front of a unit vector because it's essentially just 1 times whatever the unit vector is. So b is going to be 4i minus 4j plus 4k. C, well, that's just I plus j plus k. And then for d, I could just simply write d as just k. Okay. So how do we get the volume? Well, the volume for this tetrahedron is given by this formula. It's going to be 1 over 6 multiplied by the determinant of AB, AC, and AD. So we'll essentially be finding the determinant of a 3 by 3, and we know we're going to get a scalar when we do that, and we'll multiply that by 1 over 6, and that'll give us the volume. So let's begin by getting what we need. So we need AB. So AB, that's just B minus A. So let's get that. So that's going to be 4 minus 3. Negative 4 minus, be careful with the sign changes. That'll catch you off guard. This would be 4 minus 1, which means that AB here is going to be equal to 1, negative 3, and positive 3, which we could write as I minus 3j plus 3k. Let's get AC. So AC, that's C minus A. So we'll get that. Same principle here. It's going to be 1 minus 3. 1 minus, again, pay attention to the sign changes. Then 1 minus 1, which means that AC is going to be equal to negative 2, positive 2, and 0. So AC here is negative 2i. It's going to be a plus 2j, and we can leave it at that. Okay, that takes care of AC. We just now need AD, which I'll go to a different sheet. I'll run out of room. So let's get AD. So AD, that's D minus A. And again, all I did at the beginning was labeled the vertices basically as vectors. That way we can go ahead and do our determinant in a few. So that's D minus A. So that's 0 minus 3. I gotta keep looking back. I'll put it right here so I can look at the vertices. So that's going to be 0 minus 3, 0 minus negative 1, and a 1 minus 1. So AD is going to be negative 3, positive 1, and 0. So AD here will be negative 3I plus J. Okay, so now we got everything we need, and we can find the determinant. So it would be a 3 by 3 because we got AB, AC, and AD, so it'd be a 3 by 3, and we'll need the determinant. So all we do is stick in our components. So remember that the first row here is going to be the components of AB, which was 1, what were the components? 1, negative 3, and positive 3. Then we'll have negative 2, positive 2, and 0. And then for AD, it was negative 3, positive 1, and 0. Now, when we went ahead and not labeled, but when we went ahead and found AB, AC, and AD, notice that we left when we got a 0 for the last component, because a unit vector has a magnitude of 1, we're multiplying by 0, which just give us 0, so we don't actually have to write down k, because there's technically no k there, since we're multiplied by 0. But when you actually go to do the determinant here, for the vector component, or the unit vector component that was missing, needs to be filled in with a 0. So that's basically what you do. And how you evaluate a 3 by 3. So what you do is you pull out that 1. So we'll pull out the first entry in the first row, and we'll multiply that by the determinant of what we get when we cancel out that the column and row containing 1, which would end up being, or the first column in the first row, if you want to think about it like that. And that would just leave us with 2, 0, 1, and 0. Then that'd be minus, and then we got to pull out the second entry in the first row. Then we'll have the determinant, and we'll cancel out the row and column containing negative 3. So we'll have negative 2, 0, negative 3, and 0. Pull out the positive 3, and we'll multiply that by the determinant of what is left over when we cancel out the column and row containing positive 3, which basically means that that column would go in the first row. So what we're going to have is negative 2, positive 2, negative 3, and positive 1. Okay, so you should easily see here that the determinants that we didn't get for these two are 0. And then here, the determinant we'll get, well, it's just going to be negative 2 times 1 minus 2 times negative 3. So that would be negative 2 minus negative 6, which is basically negative 2 plus 6, which is positive 4. So we'll get 4 as a determinant for that one. And so what we'll have is 1 times 0 minus negative 3 multiplied by 0 plus 3 multiplied by 4, which obviously just gives us 12. And so when we go back to the formula, which was the volume here, and it was 1 over 6, and then we got our determinant, so we're going to multiply that by 12, and we see what we get there. So this would just be 12 over 6, which you know is 2, and that's your volume. So your final answer here, in this case, our volume, which will denote uppercase V, is going to be 2, we'll say cubic units. And that's going to be your volume. All right, so let me circle that. And hopefully everything that I did there makes sense. That's how you do it. So if you guys got any questions about it, let me know. I'll be more than happy to go over it with you. That's going to be it. And I'm going to see you guys next time.